Hello. Which of the following statements is true for all positive functions f of n? So let us consider each option. The first option, f of n square is theta of f of n square when f of n is a polynomial function. So let us consider f of n as a polynomial function of order k. Then f of n is n power k. So f of n square is n power 2k. Similarly, f of n whole square also n power k whole square also n power 2k. So when they are equal order, you can say n power 2k as less than or equal to n power 2k, or as well as n power 2k is greater than or equal to n power 2k. So it is the tight bound. So we can say that f of n square as theta of f of n whole square. So the first option holds, as the gate is giving questions which might have multiple options. So we will check the other options also. So now as the first option is true, we can say that the second option is not correct, because second option is saying that for all functions f of n square is strictly less than small o of f of n square. That means limit n tends to infinity, f of n square by f of n whole square is 0. So it's actually n power 2k by n power 2k that gives a 1. So that's not correct. Now consider the third option. The third option, f of n square as big O of f of n whole square when f of n is exponential function. So if you consider f of n as 2 power n, then f of n square is 2 power n whole square, f of n whole square is 2 power 2n. As you can see, the 2 power n square is greater than or equal to 2 power n for n greater than 2. Okay, so it gives a lower bound. So it's actually omega of f of n square. But when we consider f of n as a logarithmic function, then f of n square is 2 power, that is log n whole square, that is 2 log n. F of n square is log n whole square, and you can see that f of n square is less than or equal to f of n whole square. So from that, the fourth option is also not correct. So the final answer is only first option holds.